we are going to study another kind of rearrangement.
Wolff Rearrangement.
That is the Wolff Rearrangement. So this Wolff Rearrangement is very easiest one. Now there is some points that we have to think before starting the Wolff Rearrangement. Like a common rearrangement, R, CO, CH2, N2, under basic condition, you will end up with R. So this is called as the ketene. So this compound, it is a ketene. Now, but the question is that one, how this compound will get synthesized. So sometimes the reaction start with this compound, or sometimes there is another method such as so diazomethane. Which will give alpha azoketone. Okay, so this compound was synthesized from acyl chloride. So this is the acyl group, this is the chlorine from acyl chloride and diazomethane. So this substrate, it will get formed. Now again question is there, how this compound will get synthesized. Okay, so again there is a method such as methane, methyl chloride and sodium azide, it will use methyl azide. Now coming to this substrate, so this Wolff rearrangement, it will start let's see. So this base, it is generated because of the such as CH3, N2. If you add any base, we know that one lithium positive or negative. This R negative abstract a strong base. It abstracts a proton from the and it will give diazomethane. Okay? So how this nucleophile is generated? Did you got it? Everyone?
Once, sir.
Is it clear?
Sir, 1 second.
Now, this is your CH3N2. Azomethane. Azom is nitrogen. So this is the diazomethane. So if you add the base, alkyl lithium alkane, so Li positive or negative. Negative, it is this alkyl, it is a strong base. So it will abstract a proton from methyl group. It will abstract a proton from methyl group. So it becomes CH2 minus. and this one become a alkane and lithium positive. Is it clear?
Yes, sir.
Is it clear? So this base you have to add in a acyl chloride. This base you have to add in a acyl chloride. So this oral Wolff rearrangement, it starts with the, okay, already assume this one. I will not write it one more time. So did you got it, this one?
Yes,
Is
sir.
it clear?
Yes, sir.
Is it clear or not? Now, so this the base, this is act as a reacting reagent as well as a base. How? It will so there formation of nucleophile, the basic structure will be developed by the abstraction of this one kind of this proton from methyl ion. So here formation of negative charge. Now this is the one step rearrangement in which no charge carbene is formed. Now, no charge carbene means what? Means where will be the negative charge? Where will be the negative charge? On which atom? Nitrogen. So, and here will be the positive. So, this CH where positive, negative and positive. So, this one, it is called as the carbene. This one called as the carbene. You can represent it as a pair of the electron. So this carbon is called as the carbene. Now, once this carbene is formed, the electron deficient alkyl group migrated towards the carbene. See, listen one by one, keep one word what I am talking. The electron deficient alkyl group migrated toward the carbene. So now carbon double bond oxygen. So there is a formation of what it is? 18. So this intermediate formation takes place. Again I will explain this one more time. This is acyl chloride in which diazomethane is added. There is a formation of alpha azoketone. Now, how this product will get formed? So this negative ion attack on electron deficient carbon. So this oxygen, it will take its electron back. So it becomes O minus Cl, I will write it below, and then remaining CH2 N triple bond finally, this removal of the chloride ion will generate alpha azo ketone, will generate alpha azo ketone. This alpha azo ketone, which one again addition of diazonium ion, this methane, diazomethane, the anionic form of the diazomethane. This will take the proton, this will take the proton. So here positive means what will be the charge here?
Negative.
Negative charge. There is a formation of nucleophile on the carbon atom. Two things it will be there. First, minus N2 gas. So here positive, negative means a pair of the electron, or you can write negative, positive. So this kind of the structure is called as the carbene, where a carbon bear a negative as well as positive charge. Then after intramolecular rearrangement, this electron diffusion. So electron diffusion means what? See, this negative atom will attack on the carbonyl carbon. Simultaneously, this alkyl group attack on the carbene. So this is a one-step process. There is no intermediate that separate alkyl group with positive charge will form, not like that. This is a one-step process where the positive charge of this carbon will attack on this one of the one electron. So the leaving here, it will be the negative charge or partial. So it will attack on here. That's why it is an electron diffusion, and this is called as the no charge carbene. Is positive negative. All we know that one positive negative will cancel to each other. That's why it is called as a no charge carbon. But this carbon where positive negative charge is present, that is called as the carbene. So this electron diffusion will attack on the carbene. So finally you will get with the KT. Is it clear?
Yes, sir.
Is it clear? So on this carbene, we can study so many reactions. The one reaction I will tell you. Suppose you are adding here water. We know that one oxygen carries a lone pair of the electrons. So this lone pair of the electrons will attack here and it become here. So it attack on the carbonyl carbon. Where it will attack? On the carbonyl carbon. Now so H plus from here, where it will go? CH2. OH minus here and H plus
Here.
on this.
Hydrogen.
Is there any charge? No.
No, sir.
Now here you can see there is a formation of
Carboxylic acid.
acid. There is a formation of acid. From ketone to acid. So this was the alpha azoketone to acid. From alkyl halide to acid. Now here, if I add another reagent such as amine, so this lone pair of electron, again they will attack on the carbonyl carbon, which is the electron deficient. Deficient carbon. So again you will end up with R, NH, C double bond O, CH2, R. So means what happened here? CO, NH, R, CH2, R. Substituted amide. This group it is called as the amide. Okay, so from there we got amide. Now the third case it is, if you add alcohol, either methanol, ethanol, propanol or anyone, what will get it here? Again this lone pair will attack on carbonyl carbon and you will end up with so this functional, what it is called? Functional group? Ester. So you can add any reagent on this carbonyl electron deficient. So it should be electron rich, a nucleophilic reagent. So that will attack on this carbonyl carbon and one proton will shift toward the methylene group, that is the CH. So you can add the water, you will get acid. You can add the amine, you will get amide. You can add the alcohol, you will get ester. So this is called as the Wolff rearrangement. So in Wolff rearrangement, what is the things you need to understand? That Wolff rearrangement may be started from acyl chloride, where diazomethane is added. The nucleophilic part of the diazomethane is generated by the addition of alkyl lithium, a base which creates a negative charge in the diazonium, because strong base is required to take the proton from the CH3. So from CH3 converted into CH2. This CH2 will attack on the carbonyl carbon in such a way that alpha azoketone is formed. Take this alpha azoketone here. The second step, add again the same reagent as a base which will abstract a proton. After abstracting this proton, we will get it here CH negative. Then in one step, that N2 will get eliminated. It becomes a positive. After getting N2 eliminated, it becomes positive and negative. So this carbon is called as the no charge carbon, and this functionality where the carbon carries a pair of the electron is called as the carbene. So in one step, this electron division, migrated toward the carbon, and you will generate a ketene. The ketene functionality is nothing but CH double bond C double bond O, like amine functionality. Instead of carbon, here it is a oxygen. Amine means carbon double bond carbon, carbon, double bond carbon. This is a alene. Now you can replace this carbon with the oxygen. You will end up with the cation. So this on this electron deficient carbon, you can have the nucleophilic attack such as water, amine or alcohol. Respectively, the OH minus will attach with the carbonic carbon. H will go to the methyl compound, methyl group. Same way, this amine lone pair will attack on carbonic carbon and one H will goes toward the CH2. CH become CH2. Simultaneously, ROH will attack on this oxygen, this OH, it becomes a ester. So, by doing such kind of nucleophilic attack, it is your choice to choose any kind of the nucleophile. So, simultaneously, you will end up with the acid, because this carbonic carbon and OH is the acid functionality. This RNHCO, this is the amide functionality, and this is the ester functionality. If you plainly add NH3, the product becomes so this means that here it is a substituted amide, here it is a non-substituted amide will takes place. So this is called as the Wolff rearrangement. There is a, it is not like any migratory aptitude in the Wolff rearrangement. So it is a plain and basic rearrangement where we need to see some example. That's all. Did you understand this one?
Yes, sir.